Hi, my name is John Overacker, and this is my Fastener Lab for my Firearms Inspections and Troubleshooting class. So for this particular lab, we're going to go ahead and we're going to drill and tap this piece of aluminum plate for 3 screws. We're going to conduct a couple of various operations, including removing a broken screw, as well as going ahead and repairing a stripped screw hole. So the first thing we have to do is to go ahead and drill and tap our piece of plate. We're going to place 3 screws evenly on the center of the plate in the exact center. So we have to go ahead and measure this to determine exactly what our overall dimensions are going to be. So the piece of aluminum plate is 4.0580. And our width, 2.0725. So what we can do is we can take our trusty calculator, take our 2.0725 divided by 2. So our center line, widthwise, is at 1.03625. And we have to drill 3 holes along this line. So if we take our 4 point... So now that we know our center point is at 2.029, we can go ahead and divide that number by 2. Puts our first mark at 1.0145. And if we take those 2 numbers and add them together, 2.029, that puts our third hole at 3.0435. So now we know exactly where our center line is going to be, and we know where each of the 3 holes is going to be on our plate to evenly space them out. The next step we have to do is to go ahead and cover this with Dicam. We can use that to help mark out our locations. So I'm going to grab a piece of paper towel and be right back. Alright, we got our paper towel. I'm going to go ahead and coat our piece of aluminum with Dicam to help us mark out exactly where we're going to put our lines. It's probably going to take more than one coat, maybe not, to do this. That way we get a nice even coverage, so we can figure out exactly where we're going to mark. Now we'll just wait for it to dry and we'll be right back. Okay, our marking fluid's dried, so now we're ready to go ahead and make our center line mark. Our center line mark, per our measurements earlier, is going to be at 1.03625. So I got our calipers at 1036, just about as close as we're going to get. So we're going to go ahead and mark our material using calipers to get us the center line going down the plate. And there's our center line. So we have a nice center line across there. Alright, we're going to unlock this, and we know our first hole needs to be at 10145. So we're going to get as close as we can to get that. 10145. We're going to lock it down. And we're going to go ahead and scribe the location for our first hole. And that's done. Next thing we need to do is our center hole, which is going to be at 2029. Apologize for the dead air. It's always fun trying to get these calipers exactly where you want them. Especially digital ones, because they'll jump around a little bit on you. I'm going to lock it down at 2029. Of course, when we locked it down, it moved a little bit. Okay, the next step for us is to go ahead and start our center drilling of our holes. I've gone ahead and chucked our workpiece up in the drill press, hoping that the light is okay enough for the camera. So we're going to go ahead and these are holes that are just designed to start our holes so that we can have our drill bit not skip or move around in our workpiece. I do have a little bit of cutting fluid that I've been using, or I'm going to use, on each one of the holes, just to aid with keeping the bits cool and keeping them cutting accurately. Each hole we're going to go ahead and drill, and here we go. Use the air gun. Alright, and moving on to our next hole. Okay. And I have a feeling that the last hole is going to be out of the range of this particular vise setup, so we're going to have to rotate the piece. Make sure we get it nice and even so we get a straight drill. All three holes have been center drilled, so now we're ready to move on to our actual drilling. Okay, we've gone ahead and chucked up our actual drill bit. This is our number 31 jobber bit. And for this, we're going to put a little cutting fluid down, a little on the drill bit itself. And we're going to take it nice and easy. We're going to drill right through the piece, and we're going to do all three holes. So just bear with me while I go ahead and do this. The nice long ribbons of aluminum coming off of it is a good indication that we were getting nice good drilling. Go ahead and clean this this off here. And we got our nice drilled hole for the first one. Okay, now that we have our holes drilled, we're ready to go ahead and tap them for our screws. I went ahead and put a little bit of cutting fluid on it. So hopefully it should be not too bad to do. I'm going to try to hold our tap as straight as possible while we do this. We're applying some light pressure, downward pressure, nothing crazy. We're letting the tap do most of the work. Nice and straight, almost all the way through. Back it out a little bit. And if we did this right, it should thread in pretty easily. There we go. All the way through. Yep. Moving on to our next hole. All these holes got the cutting fluid ahead of time, just to make it easier and you didn't have to watch me putting cutting fluid on. Again, some light downward pressure, nothing crazy. This is aluminum, so it actually is a lot easier than the steel that I'm normally used to. Okay, taps all the way through. Got a little bit of aluminum on this. Just going to clean off the tap a little bit with a brush. Last one to tap is our last hole. Alright, our tap is through on the third hole. And now we're in business with 3 tapped holes, perfectly center, vertically on the workpiece, perfectly evenly spaced on the workpiece. So we're good to go to start putting our screws in and doing a couple of different maneuvers to deal with broken fasteners. Alright, the first skill we're going to work on is repairing a damaged screw head. So we're going to need 2 bits for this particular one. We need a larger full-size bit that properly fits the screw, and then we're also going to use a smaller bit in order to damage the screw head. So I'm going to go ahead and put this screw all the way down into the workpiece. Alright, so the screw is now properly in the workpiece. We're going to take a smaller bit that's too small for this, and we're going to go ahead and try to damage the screw head a little bit here. You know, if we kind of twerk it out a little bit. And hopefully now you can see that the screw head, and it's probably not going to focus very well, the screw head has been, the technical term here that we're going to use here has been boogered up. So the screw's been boogered up, we're going to go ahead and go through the process of repairing it. Now that we have our boogered up screw, we're going to go ahead and remove it from the workpiece. And we're going to go ahead and chuck the actual screw up in our vise. And we're going to use a needle file Okay, we've gone ahead and chucked up our screw in the drill. I'm going to do the best I can to keep this in frame, and it's probably going to be a little noisy, but we're going to go ahead and polish out the screw head. We got some 300 grit sandpaper, and we're just going to work it evenly until it gets nice and uniform. And now we have a screw that is ready to be blued. The first step when you use a cold bluing solution is to go ahead and clean the workpiece with a degreasing fluid of some type, generally one that doesn't leave any type of material or residue behind. So in this case we are using acetone. I'm not sure if you can catch that on the camera, but we're going to go ahead and just clean off the top of the workpiece. And what that's going to do is that's going to remove any residual dirt, grease, grime, anything like that. So we don't have to worry about the bluing solution not adhering. Just to ensure that it's been cleared off. Alright. Alright, we got ourselves this is actually 4/0 steel wool. I know the class recommended using 3/0, but this is the stuff I just happened to have on hand. I wasn't going to go out and get more when I already have something that would work. And that's it. We have ourselves our re-blackened, or re-blued anyway, gun screw. Okay, the next thing we're going to do is we are going to go ahead and cross-thread our screw. We're going to do this by actually starting it at an angle, giving it a couple turns at an angle, and as you can see, actually I'm going to move this camera a little bit, that we've gone ahead and cross-thread this screw. This one's only been a couple of revolutions, so it shouldn't be that stuck. But let's go ahead and remove our screw by using the proper screwdriver. And the easiest way to fix something like this is to go ahead and to retap the hole using the, typically we would use a larger size tap. For this particular case we're going to just try using the tap that we originally did our holes with, keeping it as straight as possible. We're going to go ahead and retap our hole. and we're going to retap it until the tap itself will move freely. And now that it's moving freely, we know that we've re-engaged those previous threads. So we'd be good to go on putting our screw back in the proper way. So we got our tap removed. We're going to start our screw by hand, and then using the proper size screwdriver, we're going to put our screw in. All the way down. I apologize for the camera angle, I'm sure you can't see that, but we now have our screw all the way in and it's properly threaded. Okay, for this particular skill, we're going to go ahead and shear off the head of a screw, and then we're going to go ahead and extract that screw and replace it. So the first thing we need to do is shear off the head of the screw. We're going to do that with a rotary tool. We are wearing gloves. We do have safety glasses on. And let's go ahead and cut this. And now our screw head is actually flush with the aluminum. Okay, now that we've finished cutting our screw head off, we just got to give ourselves a little bit of flat surface to work with. So we're going to use our little needle file here. Kind of take off the burrs on this. And now we're ready to center punch it. We're going to use our center punch to strike a hole in the exact or relatively center of the screw. This will give us a spot for our center bit to go ahead and bite into. And there we go. Okay, we got our piece set in the drill press. We're going to go ahead and center drill the center of our broken screw. Okay, we have our workpiece chucked up in the milling vise on the bench press. Going to go ahead and put a little bit of cutting fluid on the workpiece as well as on the bit. And these pair of forceps are here because actually while I was center drilling the screw head, the actual screw head is actually moving in the hole. So I think the pressure that we've put on it has actually loosened it up in the threads. So my concern is that it's just going to pop out. So this is on here just to prevent it from going anywhere. Those may move as we start to drill, but we'll keep an eye on that. Now that we've drilled this, we're going to go ahead and run our screw extractor, and it should pop right out. Actually, our screw extractor raised it. Let's see if we can try it one more time. So the screw extractor started to remove it. Now its head is significantly above the workpiece. Might be able to grab it with this little needle nose. Yep. And it looks like the screw's going to come out. Alright, looks like when we were using the screw extractor, we had drilled out enough of the center of the screw that it actually broke the side of the screw as the screw extractor was running. It started to pull it out, and then it stopped just once it had reached over the top of the surface. So we did end up getting the screw out with just a little bit of help from a pair of needle nose. The next part is to go ahead and take one of our other screws and put it in that hole. Supposedly, if we've done this correctly, the screw should just fit in that hole. When our screw extractor let go on that screw, it did kind of booger up the hole a little bit. I'm hoping that the head of the screw will actually cover that little spot that kind of got boogered up. And actually, I think we lucked out. It looks like it does. So we went ahead and did that correctly. The screw, we were able to put a new screw right in that hole. So that will conclude this part of the Fastener Lab. We went ahead and for this particular one we did a repair to screw head that got boogered up by the wrong size screwdriver. We also went ahead and retapped one of our holes that we had cross-threaded, and then we also removed a sheared off screw head, and were able to save the hole to go ahead and put another screw in. We also did use some skills in the beginning of this for drilling, for tapping our holes, for doing measuring and layout, and essentially those are all the skills that were involved with this lab.